Hello everyone, welcome everyone to the yet another edition of Avail's Whiteboard series. Today we have Kautuk, founder of Stackr Labs, who's joined us to explain Stackr in detail. Welcome Kautuk.
Thank you so much for having me here. It's very interesting to be a part of that series. Yeah.
Thanks Kautuk. And today we'll, I think, focus on what Stackr's architecture is, but I think Stackr's focus is on developing app-specific chains, and they're coming up with a newer construction which were possible in general app-specific chains, maybe with no VM at all, for example. But I will leave Kautuk to do the explaining. But Kautuk, if you could start with a brief introduction of yourself, that would help the audience a little bit to just give some context.
Yeah, of course. Hey everyone, my name is Kautuk. I've been looking into and researching about L2 scaling since a while. So previously I was working with the Ethereum Foundation. So I worked on the Hubble optimistic rollup project. And then right after that, I worked on the BLS wallet project. Meanwhile, I also had LifePeer to move their protocol from mainnet L1 to Arbitrum. So I built the bridges. And since I think a year and a half, I had been focused on building rollups in a sense, it provides more flexibility to developers, and they can just build applications in a more easy way, or in general programming languages, I would say.
Yeah, cool. So I think this session will provide us opportunity for everyone to understand what the rollup workflow is, what the data flow is, what is required on the base layer, what is required on the rollup nodes, for example, what kind of constructions are possible, pessimistic, optimistic, ZK. And so because we are used to kind of thinking about rollups in a very EVM centric point of view, and so hopefully this session will be an eye opener for people who want to see different types of rollup constructions. So maybe Kautuk, we can begin with initially just the outline of your of a rollup in general. Let's not talk about the specific rollup implementation of yours or any other EVMs, but in general, let's start with the workflow of a typical rollup life cycle, and then we can maybe explain first in a pessimistic scenario, then in an optimistic scenario, and let's say in a ZK scenario, right? And for now, we can assume that the base layer has a smart contract layer like Ethereum, for example, just to keep it simple. So yeah, you can use the whiteboard if you want to.
Yeah, so just to get a sense of rollups in general, essentially, like you mentioned, currently the idea is that most rollups are EVM chains, or chains and needs to run a VM, and then that's supposed to happen. But all in all, if we look at first principles, rollups are just deterministic computation of result off chain, and then you just do the compute and then you post it back on L1. And since we are assuming that there is a smart contract, you have a way of verifying all the compute in case of if you need to do that. So I think just drawing a very simple structure, if we have a L1 going on and there is a rollup that is on top of it, and there is a smart contract which governs the rollup. So what essentially happens is that you just send transactions to the rollup. The rollup basically executes it and then just posts transaction data. It could be state diffs, it could be just the user transactions on chain. And in case of, I think in case of pessimistic, all the transactions are re-executed first and then posted on L1. In case of optimistic, they are posted on L1, but it's an assumption that the transactions are correct. But still there is a way on chain to verify those transactions by re-executing them using fraud proofs. And in case of ZK, I think all the rollup transaction is converted into a snark and then posted on L1, so that it's you just need to verify the proof instead of verifying the whole transaction. So that's what
Cool. So just to make it slightly more clear, right? So in general, users submit transaction to the rollup. The rollup in turn takes the transaction data, maybe encodes it, packages it, compresses it, and sends it to this L1. Why is that important? Is because there is a sequence of the ordered transaction list is there, And so this is the source of truth for the re-execution if it were to happen, right? Like, and so basically, irrespective of whether it's a pessimistic or a optimistic or a ZK rollup, the act of putting the ordered set of transactions on L1 ensures that that rollup inherits the security of the base layer.
chain. Yeah.
Because anyone can then re-execute those transactions in that order.
Yeah.
Now, whether it is pessimistic, optimistic, or ZK, kind of compresses the verification time, or in the sense that re-execution might take the longest. An optimistic is not everyone needs to re-execute it, for example, and in a ZK there is like a mathematical guarantee of that, right? Like so basically, so these are primarily the three broad kinds of constructions that are possible, right? Like, so now in this context, right, like now let's get into more detail regarding Stackr, right? Like, I mean, so we have now identified that there is transactional data going here, and then either you do re-execution optimistically or you do, like ZK validity proofs, right? Like, and for now, I think let's restrict ourselves to first the pessimistic, which is the more simpler kind, right? Like, so let's now get into a little bit deep on Stackr, if you.
Yeah, of course.
Yeah.
So for Stackr, like the main idea, and it's kind of inspired from like my previous work on Hubble. So what just like briefly explain. So Hubble is basically an ERC20 transfer rollup, which came out of the Reddit Bake-Off challenge, and the idea behind it was that it can only perform ERC20 transfers, and for doing that it doesn't rely on any VM, it doesn't have smart contracts or anything. It does limit its functionality, but when the functionality it's built for, which is the token transfer, it does it very efficiently because you don't have redundant data going on that. And that is kind of like the base inspiration for Stackr as well. Like if you are able to do token transfer, you are able to do NFT transfer, you are able to do you can build DEXs, you can build games, you can build anything you want to do if you just follow the principles that we talked about. So rollups doesn't need to be a chain. You can just be like a standalone application which has its own runtime, and that runtime executes your transaction or whatever logic that is embedded in the rollup, and then that logic then the transaction after going through that logic and the state transition ends up on L1, and that's how we envision Stackr to be, and that's the SDK that allows you to do that. It takes care of all the heavy lifting on the rollup side, so that the developer can only doesn't need to worry about that, and only need to take care of how they are building the state machine, and they can do it in like JavaScript and Python initially, and going forward we'll have SDK for like other environments as well.
Okay. So maybe let's kind of draw out the like architecture at a broad level. So initially you're talking about like the runtime on the app architecture, right? Like, so maybe we can draw that like basically out.
Of course. So let's say like in our system we envision that there are multiple applications going on. So I'll just like draw 3 of them, maybe just call it app 1, app 2 and app 3. And since we are like focused on like general purpose languages, so app 1 can be in JavaScript, app 2 can be in Python, and app 3 can like again be in JavaScript, something like that. All of these applications have their own states, so we are focused on like state isolation, so that in regular L1s, like it can think of it as it provides the execution environment as well as it provides the shared state. But for us, we are kind of isolating both of them, so every application has its own state. Just like probably make a database, something like that. This is a database thing.
Yeah. Don't worry.
Yeah, so every application has its own state, and it has its own runtime in whatever like environment that it is being built. So this is how the application structure would look like, but on its own it doesn't do anything. So we have another layer below it, which is like the aggregator layer. So this aggregator layer can be thought of as a coordinator layer. And right now, I'll talk about like the modes it is running in. So it's initially pessimistic, and we'll progressively move towards it. I'll just talk about it in a little bit. So what essentially happens is there are users who wants to interact with these applications. So They send transactions to these applications. The applications execute those transactions and then send the outputs to the aggregator. And once I'll come to the aggregator in a little bit, but then after collecting all the transactions and verifying them, the aggregator then posts it on the parent chain. So over here it's the L1. So it's Ethereum right now, and going forward we can change that as well. Yeah.
Okay. So in general, can you get a little more deep into what is happening at the aggregator level here?
Yeah. So basically, right now, since every application has its state and execution environment separately, so what that allows us to do is to have a separate transaction format for each application. So let's say application 3 wants to do something, it can have its own transaction parameters. And that can be very different from the transaction parameters for application 1. For us, we call these transactions actions because it might get confusing with the L1 transaction and stuff. So I'll just use actions going forward. Basically, what happens is the user submits an action request to the application. The application just uses its state transition function and applies that state on its whatever the current state is. So it takes the action, uses the STF that was defined on the application, the state transition function, and then just applies it on a state and sends it to the aggregator. So let's say the application collected 10 transactions from the user. It creates a batch out of it. So there is a batch of 10 transactions. It signs the batch and then it moves it to the aggregator. The aggregator then collects batches from all the applications. So from application 1, from application 2, application 3, and then creates a bundle of these batches, and this bundle is posted on L1 altogether.
Cool. Makes sense. So basically, ultimately what is happening on the L1, as I understand, is for app 1 you'll have the ordered set of transactions here, and for app 2 and app 3 and so on, right?
Yeah.
And in general, any third party can go to L1 directly,
yeah,
and verify the state of any app they want, right?
Yeah, that is true. So the idea would be all the transaction data of application 1 from its genesis is gonna be present on L1. So let's say one day the application 1 disappears or something, anyone can else just pick up the application 1 state machine and then rebuild the states from genesis to present, and then have another copy of app 1 going on. And I think that's the beauty of rollups, that the application doesn't disappear like that.
Yeah, absolutely. So in general, can you talk a bit about I know you're still working on finalizing the runtime, etc., right? But how are you thinking about this right now, and what possibilities you envision in the future, right? What is this runtime really looking at right now?
Yeah, of course. So right now this application 1 is deployed on let's say in an environment where it supports JavaScript. So it could be a Linux runtime or something like that. What it essentially does, it runs the JS program like any other backend program of some sort, and that same environment the SDK packages it into a full node for the application. And this full node is kind of given to the aggregator to re-execute. So like I mentioned, it's currently running in a pessimistic mode. So all the transactions that are coming in from the application are once executed by the aggregator and then only posted on L1. So that's the pessimistic mode we are running in at the moment. And also on L1, it's kind of a sovereign setup, so that we don't have a smart contract which enshrines the logic as of now. But going forward, we'll move towards more of a enshrine fraud-proof mechanism, and then after that we'll also have a ZK-based mechanism going on. But for now, the application 1 exposes its logic as a full node. Then this full node is given to the aggregator. The aggregator uses this node, and since the aggregator is stateless, it just picks up the previous state from L1, takes in the ordered batches from the application, and then computes the new batch header or the batch root, and then it checks if the application was right or not. So that's the current setup at the moment.
Okay, makes sense. So at the moment, in general, how are you thinking about state, right? Like specifically, what data structures are you looking at the moment, right? When you're saying what is this state at the moment, and How are you thinking about state in general?
Yeah, so I think initially the SDK will be bundling like a default Merkle tree as the state which the developers can build upon. They can customize the leaf of the Merkle tree, and that is the same for most of the application. And you can just like write a state transition function to update that leaf. So the STF could look different for the application, but the base data structure that we will be bundling initially would be like a Merkle tree kind of structure. And yeah, that's that answer. Yeah.
Okay. So I think we've gone through this architecture. We've basically gone through the pessimistic nature of this construction, right? Like, I mean, and I'm assuming that because the aggregator re-executes the node, there are no invalid transactions that get posted to L1, correct?
Yes.
For now. Cool. In general, this runtime that you have, right? Like for now, you are assuming that the aggregator will run all these full nodes. For now, is there any incentive that is paid to the, like, what is the incentive for the aggregator here?
So basically, what we are thinking about right now is that the aggregator could be like a proof of stake or a delegated proof of stake system, wherein like they need to stake to actually participate in the layer. And this is like a public network, so anyone can join it and then start verifying the transaction. The application also like pays a fee to the aggregator for like running its compute. Otherwise, like why would the aggregator would want to do that? Like the application provides its batches to the aggregator, and also like a fees that, hey, just verify my transactions before posting on L1. So that's the incentive mechanism for the aggregator as of now in this current design.
Okay, makes sense. And how about the app like authentication and like fee mechanism? Like how are you thinking about this?
Yeah, so
can different apps have different strategies?
Yeah, of course. Like the interesting part of that is that this is a very Web 2 kind of setup. So you don't necessarily need to have like entirely like how you interact with wallets. Like of course the user can definitely send like signed messages to the application using their wallet. So user can use a wallet to send signed messages or something like that. And since these are actions, these are like not actual like on-chain transactions. So these are just like signed messages. Either you can do that, or you can kind of like build towards what like account abstraction is doing. It's not the same thing, but kind of like if application 3 embeds like a OAuth plugin or something like that. So you don't necessarily even need a user wallet. You can just like sign in using OAuth, and this application verifies it and creates a account for you, and then that account can be verified in the Merkle tree and stuff. So the application can just like create a paywall or like whatever auth mechanism that regular APIs have in the Web 2 world. So that's also possible over here.
Okay. I think that sounds great. I mean that basically means that like with this rollup or app construction, you're also opening up areas in which access to the rollup can be, there can be a lot of experiments on that, right? Like it's not only through like public private key pair kind of interactions, but also more conventional Web 2 style authentication, right? Like, I mean, I think the only thing is if you're able to handle spam on this, like as long as the methodology handles spam, like any authentication measure should work.
Yep. Of course. I think to handle that right now in the Web3 world, you have to pay a gas fee. So the application can also implement a fee mechanism for the user. So like before like authenticating or before paying that, it can just request tokens directly from the user, so that once it processes it, it just like deducts from like another rollup, or like once we have interoperability, like another thing is like the one application can just like do like banking for the application. So application can just deduct some fees for like interacting with it, and that will just prevent spam on that.
Okay, makes sense. In general, how are you thinking about this entire construction from optimistic scenario, right? Like I think you mentioned in the past that you'll start with pessimistic, but you're looking at optimistic, and maybe at some point in time a ZK construct, right? Like, so how are you thinking about that? So from because if you look at this construction at the moment, you're in the pessimistic scenario, you're not looking at a contract on the base layer. So this should also work on layers like Avail, Celestia,
Yeah,
and
yeah.
others, right? Like in the case of a optimistic or a ZK, like especially in ZK also you have now recursive proof schemes, right? Like so just your rough thinking about how this would evolve in those scenarios. Maybe we can start with the optimistic one, then we can go to the
Yeah,
ZK.
I mean, I think both of them kind of overlaps as well, because once you get generate like ZK. Okay, but starting with optimistic, I think the one way to go forward would be like the application, instead of like the aggregator executing everything, it can just like create a bundle and post it on L1, and then there is a smart contract which enshrines the logic of that application to be present as a guard against that. So anyone can just come in and say that, okay, hey, there was like blob with this particular ID posted on L1. I want to check the contents of it. Or someone is like running a watcher node who's checking it, and they want to something bad happened over here, and like they want to verify it. So they can just like use the contract that is deployed on L1 that enshrines the logic of the application to pull data from this block and just execute that and like see if it was a valid state transition or not. For us right now, the entire point of like having an aggregator and like having re-execution in between was to reduce the confirmation and finality times. So in case of like optimistic case, it's like 7 days usually, and with that, since aggregator is already executing the transaction, you can just like say, since we had a pre-consensus on the aggregator side, you don't need to wait for 7 days. You can just like give it to like 1 day or half a day or something like that. So what we are thinking of is in terms of confirmation levels. So there is a C1 confirmation level at the app layer, there is a C2 confirmation at the aggregator layer, and at C3 confirmation layer level at the L1 layer. And this kind of like changes how applications today think about UX. So for applications like games who wants like very faster execution time, and they do not care about correctness immediately, like it's okay to have a complete game session and then you wait for the game to complete and then you look for the confirmation time. So they can build experiences like that. So we assume that the C1 confirmation level, since the application is running its own environment, could be in like magnitude of milliseconds. At the aggregator level, once it re-executes it, it's going to be like in somewhere in like a few seconds, and like at the C3 level it could be like somewhere between a few minutes, and if you are looking at optimistic case, it could be like a few days or something like that. But yeah, this is the kind of experiences that the application can build towards, and this is very great for like high frequency applications, something like that.
Okay. So I mean, I think this will be especially useful for, let's say, like more like games or Web2 style, which requires maybe millisecond request responses. Like so. I think this is pretty great. Like, can we spend a little bit time on like the developer experience that this kind of construction brings to, in respect to, let's say, more EVM or like dApps, right? Like I mean. So certainly you touched on the language thing, but there are these properties of like app specific state. Like so, for example, EVM developers today need to run things like indexers, for example, and like because they have state contention, you need to do transaction relay, retry infra, for example, and all that, right? Like I mean, and I think this kind of goes away with this kind of construction, right? Like so, how would you pitch this to developers from that lens?
No, of course. Like I think that's the entire idea behind the SDK. So if I just draw a comparison between that, so if this box represents the entire SDK, the developer would just need to focus on like this chunk of like the development experience, and this is mostly the state machine, how they are envisioning it. All the storage related stuff, all the networking related stuff, and all the data structures and all the stuff about communication with the aggregator and retries, like you mentioned, all of these things are taken care inside the SDK. And just the state generation part, and also the we are kind of like bundling in like a API which the users will interact with. So it's kind of it's a little bit of work for the developers, but most of the heavy lifting for communicating with the aggregator, the RPC calls and those kind of things are bundled in the SDK. So this is how the developer experience would look like. And it's interesting because all of these things are agnostic to the environment that they are building in, and we'll be bundling these things inside, and all of the small things that the developer needs to take care of would be like in JavaScript, Python, or whatever. So that's the entirety of like the SDK. Yeah.
Okay. No, I think that's an important point. So essentially, like the kind of abstraction that Web 2 developers are used to today, right? Like,
Yeah.
I mean, like Web 2 developers don't get into, like how does the networking work, or like how does the lower level stack work, right? Like
Yeah.
they're just working at a very higher level of abstraction, and that is what is missing today.
Yeah.
In especially in Web 3, right? Like so what I just want to emphasize, right? Like what you're really saying is the developers will just need to bring their business app logic and let's say their data model, and they should be able to get started with the Stackr SDK.
Yeah,
Is that right?
that's the plan. Yeah.
Correct. And you also mentioned this API part, right? Like, I mean, does that mean that you'll be able to provide like developers for the chain, for example, will be able to provide things like REST API interfaces and such, so that like it could potentially be used by other Web 2 apps as well?
Yeah, exactly. That's the point. So the way you are communicating with the application in the initial design that we have are through REST API only. So there could be like right now you have to build like a RPC call for doing the transaction to encompass all the data structures and stuff. So for us, it could be like there is an app. And this is the endpoint which the application exposes, and there would be like a transaction endpoint, and then there would be like a send transaction. In the body, you just add in the params, and yeah, that's simply how you interact with the application. So it's exactly like how backends work today, but instead of like a Web 2 backend, it's kind of like a Web 3 backend, something like that. Okay. If a hybrid Web 2.5, if you say.
Yeah. Okay, makes sense. In general, how are you thinking about like the GTM for this at the moment, right? Like, I mean, where do you think you're going to pilot this first, for example?
Yeah, of course. So I think one interesting position that this puts us in is in the Web 2.5 space as well. So right now, and also like this thing doesn't like it is more suitable for like early stage projects who wants to build in a different way. So since you cannot like bring in an existing protocol on top, and you just build it in a different way, and in a very like Web 2 kind of way. So we are kind of like positioning ourselves in the Web 2.5 space. So let's say you're building an application which has a Web 2 component, and you want some part of it to be decentralized. So you can use this to do that, or you could build like entire game engines on top of it. So you mentioned like what are some early things that you're thinking of. So I think gaming is definitely one key areas of focus, but technically you can build anything out of it. So payment not payment channels, I mean like payment infrastructure, gaming infrastructure, just like DeFi stuff. And also it also opens up to like any kind of like general purpose distributed computing. So this application need not be like a single node. You can just like have a distributed system which does maybe that runs a machine learning model or something like that. So you could build that, and since it's in Python, so most of the machine learning models uses like Python as the backend. So maybe you can build that. So yeah, the possibilities are like endless.
Okay. No, makes sense. Any intuition in terms of how these app chains can talk to each other?
Yeah.
How would that roughly work?
Yeah, so I think it's not very clear. This aggregator is kind of like the coordinator layer in between the applications. So since it's like a step between the L1 and the application, it works as a coordinator right here. So application can directly communicate with each other through the aggregator network. So just make a little bit space. So how this would look like is something like this. So the application can just like use aggregator, and it's sort of like IB-ish kind of ways that application communicates. So it sends its data to the aggregator verifies it, moves it to the application, then the other application that verifies it, it sends it back, and we have like confirmation from both the application. So it's async for right now. It doesn't need to be atomic, but yeah, this is like the thing that we're mentioning. Obviously, we are a little bit early in the interop side of things, but we see the aggregator layer acting acting as a coordinator for like these async messages.
Okay, makes sense. So for now, I think what you're saying is because the aggregator runs all the full nodes, or like it has access to the runtimes for all the app chains. So like there will be a protocol where like some protocol for messaging, like standard protocol for messaging, and which the aggregator treats it as a special message and executes it, and then sends it to let's say app 3.
Yeah, that's how we plan to do it. So there could be like transaction types. So one transaction type could be just like a single application transaction, and another transaction type could be like a multi-action thing. We call it multi-action, and that can be understood by the aggregator and can just like do like a two-phase commit or like whatever approach that we go with it. And like you mentioned, like correctly mentioned, that it's because the aggregator has access to the runtime of this application, and that is why it's possible.
Okay, sounds good. I think we have now like a full idea of the architecture for now. I think maybe one useful thing we could do is, like I've always wondered, like, like let's say something like Uniswap, for example, right? Like, so it was built as an AMM on Ethereum because it was very expensive to run an order book exchange on Ethereum, right? Like, but like even on L2 the same thing has happened, that like Uniswap gets like AMMs get deployed on L2. But I've always thought like like with the rollup construct, right, like you can actually do better constructions like an order book exchange directly on L2, and I think that would lend itself to that. I mean, do you think we can go through that a bit? I mean, we can brainstorm and see how that architecture ends up like.
Yeah, of course. I think we already have like a few pieces here which can, let me just remove this from here. And since we are going with the whole micro-rollup thing, which is kind of like we borrowed it from the Web2 world of microservices, and it's like correct. It's like the entire setup for the order book could look something like this. So let's say these applications, instead of being like standalone applications, these are just like micro logic for a particular application. And let's say we are building like a order book. So let's call it a micro-rollup unit for now. So what essentially can happen is that micro-rollup 1 can handle the like the matching engine. Micro-rollup 2 could just be like an order book. And the MRU3 is basically where all the liquidity is, right? So we can just call it pool. So how going forward could look like the user submits a transaction which goes into the order book, then the order book messages the matching engine to like find the pair, and then the matching engine, after finding it, like orders the pool that okay, here this the place, now do the swap. Once that is executed, all the transaction, like this is like a 3-level multi-action transaction, the aggregator can just like verify it and then just post it on L1. So and all of this, like this can like live in independent like environment. So matching engine could be built in Python. You could use any kind of logic for that. The order book could be like maybe like it needs to be faster. It could be like C or C++ or whatever, and the pool could just be like a Merkle tree which like holds all the liquidity, something like that. So yeah, that's setup there.
Okay. So I think basically like this order book engine would be very nice to do a POC with Stackr in general, because like you are able to use arbitrary modules or code components here to kind of optimize on that, and all of this is done typically off chain, right? Like I mean, and so essentially, but you are kind of putting all the transactional data, maybe the swap data, for example, along with some of the order information on here, so that like it is reconstructable later. Right, like so so in general, so I certainly I would like to see someone from the community coming up and like doing this kind of a thing, because in general AMMs are not liquidity efficient, and so if we have this very nice rollup construction, we should certainly be playing with it to get better constructions in general. How are you thinking in terms of like cost in general, right? Like I mean, in terms of, let's say, the L1 layer data availability, and like in general here, how are you thinking in terms of cost, or in general on the aggregator, what is the unit that you will be charging in? Will there be a token, for example? Like, how are you thinking about like fee mechanisms?
Yeah, so I think we are still researching on that part. We haven't really converged on like what it could look like. But for like the initial ideas that we have is like the applications will be paying the aggregator for like doing its verification, and then the aggregator would be paying L1 fees. And like I mentioned, it's gonna be like a proof of stake system. So the aggregator will just like anyone who wants to run a node will just stake into the system and then just start participating in the network, and they'll get rewarded based on rounds and based on slots or whatever. And I think the fee exactly is something which we haven't like fully converged on at the moment, but it would be something like cost of compute. So if they are running a node for the application, they can just like charge based on like whatever amount of compute that the node took, and then they can just charge the application for it. Yeah, that's like the high level of it.
Okay, makes sense. In general, do you envision the use of Stackr in more standalone applications, or are you also thinking in terms of like connecting to liquidity venues, for example, and so on, right? Like, so, and how are you thinking about it?
Yeah, so I see this network in itself could be a thing, and like all the applications within the network it will work with, but definitely network is something which should not be a closed thing. It should be opened out. So in terms of liquidity and those kind of things, one initial idea that we have, let's say like this was a pool example in the order book thing. So one really interesting thing that we want to do is to build like a liquidity hub, and this hub is kind of like a bank in the network, and this hub holds all the liquidity. And the best part about this structure is that each rollup or each micro rollup doesn't need to own its own liquidity. It can just rely on this hub, which acts as a bank, and just do transfer on behalf of the rollup. So this gets away with the liquidity fragmentation bit as well, and this hub can actually be opened up outside the network. So this could be an external thing wherein like liquidity providers like maybe like Catalyst or someone could come in and just like take over this hub, and they are like feeding it liquidity, and then this liquidity is consumed within the application, and it can also go out from this hub outside the network. So that's like the current thinking right now.
Okay. Anything that changes for the user from from access mechanism, right? Like, I mean, of course you said that like people can use wallets, but other authentication measures, right? Like, but how do you think this will change user behavior significantly as compared to the status quo?
Yeah, I mean, like, if anything, it's gonna get a little friendlier. So right now, the biggest UX issue with our with the Web3 part is that you need to have a wallet which needs to have tokens, and you need to pay gas and stuff. So first of all, like even if you go with the wallet route, you don't need to have tokens because just signed messages, and all the like charges or whatever is like is up to the app, so they can charge it per transaction, or like basically like API pricing, which is very similar to how Web2 does it as of now. And again, like you can have like email based authentication, email based interaction with the application. So that gives a very user friendly experience, or actually like something which is which the user is already familiar with. Like if you go out and find an average job, everyone knows how to sign up on Twitter or like write a post. You never see someone like when you're clicking on a tweet, a wallet pops up and you have to do some stuff. So I think that is the kind of user experience that we don't want to do. So this kind of opens it up more from a Web2 perspective.
Okay, makes sense. How do you think about the general, like, so all this, the whole construction relies on, like reliable data availability, right? Like, I mean, so how are you thinking about the landscape in general, right? Like, of course, Ethereum is option, but like in general, what do you think are the other options out there? How are you thinking about it?
Yeah, of course. So I think in terms of rollup landscape, we like we discussed like right in the beginning, that the data needs to be present so that anyone could just rebuild the state and like find the current state of the rollup, and that needs to be present in a system which is secure and always available at the moment, so that anyone can just like do a request and find the commits and like get the data back. And for that regard, I think data availability layers like Avail, like yourself, and like Celestia, and maybe Eigendy is also coming up with it. So these players can like make a key role on that one, that also like help us to put like larger data blobs on the system. And I think that's and also like help us with like faster finality. Like L1 takes a few minutes, and this can like even reduce, I said, milliseconds, seconds, and like a few minutes. Then if this is replaced by a delay or something, it could just like get even faster. And since we are already pre-checking the transactions over here, the DLA that we are building on towards doesn't even need to have like a contract support. Since we are already executing it, we just like put the data there and like be rest assured that it's gonna be there for there. Yeah.
Okay, makes sense. Have you also looked into light clients from, let's say, Avail, Celestia, in general, in terms of how they can help? Because essentially light clients help give like in generally from an execution point of view, full node has to kind of download all the data and then, but in general in a light client, like you can basically get a very high probability of data availability guarantee.
Yep.
Of course, when you have to re-execute transactions, you still need to download all the data, but like, have you thought about how to incorporate light clients into the design?
Yeah, of course. So I think one essential thing would be like data indexing. So for all these applications, they are doing like so much amount of compute every second, and like one of the major things would be to actually see that transaction, and for that we need to build block explorers or transaction explorers in this space. So I think there's definitely a need for building like indexers, and these indexers can actually run like light clients of the DA mechanisms. So that we are able to extract whatever data that is being computed or being matched upon, and then these light clients can run inside a indexer, and then that indexer could be used to build like block explorers, which is going to be like a value-added service to the network.
Okay. Yeah, I mean, maybe the second, maybe it's not, because we are coming from a very Ethereum rollup kind of a thing, and so like block explorers are pretty important, like those kind of thing, right? Like, but here in a more app chain kind of a platform where like maybe there may be 1,000 apps, and you can't really have 1,000 explorers, right? Like, so how are you thinking from that? Is it even important, right? Like, because in, let's say, from a microservices kind of point of view, right? Like, no one really gets into all the data, but this is like a hybrid between public blockchains and microservices, right? Like, so how do you think that whole explorer thing evolves?
Yeah, so as you mentioned, like the current explorer design is definitely not suitable for like this kind of application. So we probably have to come up with a different kind of explorer mechanism, because people would like, since this is like a hybrid thing, it's not completely public, it's not completely private, but still people want to have access to like a public view of like whatever they are doing. So I think we'll have to come up with like a novel explorer design, which kind of has, honestly haven't like given a lot of thought into like how the explorer would look like, where it's gonna be like right now explorers are mostly about the blocks and not about the smart contract. Like, applications are not first class citizen of an explorer. So if we could come up with a design in which applications are a first class citizen of a block explorer, then that would make a lot more sense in this kind of a setup.
Yeah, I think that was a good statement. Apps are not first class citizens of the Explorer, because right now the focus is on the chain, not the application. So I think that would be a pretty good UX to kind of walk through at some point in time. In general, I think I'm mostly now. I think we have been through the entire architecture. Any other things that you want to touch upon on the architecture a bit?
Yeah, I think there are a couple of points which I just skimmed over, which is I think where the ordering happens and stuff. So I can just briefly talk about it. Cool. So right now the focus is on letting the application handle the ordering themselves. And the way we are thinking of it right now is like in most architectures, like sequencer is very important part of this. But for us, we want to delegate the work of ordering and sequencing to the app itself. In the initial design, it would just be the application like doing the sequencing themselves. So So it could be like a first in first out model, or like how current gen like general purpose rollup have it, like the sequencer does like that first in first out kind of thing. But since we don't have that kind of setup, each app is different, so probably the app itself is doing the first in first out. And then later on, as we develop, the application can just like outsource the sequencing work to like a shared sequencer. So what essentially would happen is that the application will have an ordered list of transaction which will be sent to like shared sequencer services. It could be anyone, and like the shared sequencer will basically use the same node that we developed for the aggregator to perform like permutations or whatever strategy they want to use, and they'll just return the so this was an unordered list of transaction, and they will just return an ordered list of transaction to the application. Our major focus is on execution, so we are prioritizing execution first, and that's why we want to do the sequencing at the app level itself, so that it's much faster and like doesn't need to rely on like some other thing. And that is also like a interesting UX or like application experience that we think of. It might open other possibilities as well, so we'll see how that would work out, but this is the bet that we are taking on as of now.
Okay, that sounds good. Essentially what you're saying is this will end up being the proposer, and like the block will come from here.
Yeah, exactly like that.
Makes sense. In general, anything else you want to touch upon?
Yeah, I think that mostly covers up like the initial design thoughts that we have. On a higher level, of course, there are so many more details, but you don't have like that much amount of scope right now. Yeah.
Okay. In general, tell us a little bit more about the development stage, the team. Like you recently raised some funding. Congratulations. So,
yeah, thank you so much.
I mean, I think the audience would like to get more context.
Yeah, so we like you mentioned, we just recently raised a round, and we haven't announced it yet. It's gonna come out in a little bit. Yeah, some alpha, but so the team is building strong. So we are like somewhat there in the development cycle, so that we are able to release like a V0 of the SDK. We are planning to do like a Q4 release for like some closed testers and like for early adopters or something like that. Basically, we want to build applications with a variety of use cases, so that we also structure the SDK and prioritize more basically where the demand is coming from. So that's the idea, and we are definitely looking for more collaborators. So always like wanting to grow the team so that people get this faster basically. So that's the idea, and that's pretty much it on the development side. So Q4 release and like working with some close partners and like looking for collaborators.
Okay. Sounds good. And how big is the team size now?
Oh, it's just 5 people for now. Yeah.
Okay. And is it a distributed team?
Yeah, it's completely distributed. So 2 guys are working from India. There are 2 guys from the USA, and I'm also like shifting between India and USA for a little bit. But I'm moving back to India after this conference, and like probably will be there for a little bit.
Okay. And you were recently part of the A16Z crypto startup school as well, right? Like, can you tell us a little bit about your experience there, and would you recommend that to projects as well?
Yeah, of course. So the CSS program was like a very interesting like it was an interesting experience for me. So coming in from like a completely engineering background, entrepreneurship was something which I did not have any idea about. I always like from my childhood I was to build a project that was my own, and like I am working towards just like delivering and stuff, but I had like not a lot of idea on how the marketing, how the BD and those kind of things would work. So I think CSS really helped me with that. They had like a lot of presentations and stuff on how to actually build your product, how to actually think about the market, put your product out. They also had like a good amount of like founders of bigger projects coming in who talked about their journey with their product. So overall it was fun. Also met a few good people over there, made friends there who are also working on their own project, and that was pretty exciting. And I got to see LA, which was like one of my I don't know. I really wanted to go there because of this game called GTA 5, and that's based in LA. So I keep saying that everywhere, but like it was just interesting and how they modeled the game according to the city. So that was like the most interesting part for me.
Okay. Fair enough. I think I think this has been great. I think basically, thank you for taking the time out to go through the architecture with us in detail. Probably closing thoughts is like, do your parents know what do you do? Like, how do you explain that?
I don't think so. Like, it is very hard, and I think the objective would be to build something so that my parents understand it. Like, that's the goal. But yeah, no.
It's pretty hard to get parents to understand what we do.
Initially, when I was like working in this, like I was getting paid in tokens and stuff, like no money was coming to me. I was like, do you actually do a real job? Like how does that work out? Are you like, is it all a scheme? Will you be able to survive and something like that? So that was the initial thing. But slowly and gradually we thought, okay, I think last year when the market was very high and like everyone was doing it, probably that time they got it. Okay, there is some value to it. But right after that ended, it was like, oh, just stop doing that. Take all your tokens, whatever you're holding it, convert it into fiat and just like leave everything. I'm like, nah.
Cool. Okay, thanks Kautuk again, and I think it was a great informative session, and like we learned a lot from it. Hopefully the audience will also learn a lot from it, and best of luck for the upcoming POC.
Yeah, and thank you so much for like inviting me and like having me part of this thing. I think this is like a very good, for me also, it's like a very good source of like putting the word out, like telling to people what I'm building. So yeah, thank you so much for that as well.
Yeah. Cool. Our pleasure. Thank you.
Yeah.